Hi, welcome to CSE114 Introduction to Object Oriented Programming, and today we are looking at a very important construct in programming called loops. Loops are also called iterative constructs. So let's see what do we have here and what is the motivation behind having loops in Java. So the reason being, sometimes you want to do a similar kind of thing multiple times. So for that case, loops are very helpful. Let's start with a very simple, case where for some reason you want to print the same statement multiple times. So here, assume that I want you to print welcome to Java multiple times, and this could be 5 times, 6 times, 10 times. So how should you do that? You have to simply print welcome to Java. So let me take you to the Eclipse, and let's try to do it. So here I already have written system.out, so I should change that to welcome to Java. Okay, so we know that if I run this program, I should get one line printed out as welcome to Java. Now if I make it slightly complicated and I ask you to print this statement twice, well, it's not difficult. What you will do, you will type it multiple times, as you might type the same statement which I have on line number 4 one more time, or you can just do control C control V the way I did. I copied everything from line number 4 and printed that on line number 5. Let me save that and run that again. Okay, good. So I got this thing to print twice. Well, if you say do it 6 times, then what I'll do, I will be little smart, and I'm copying 2 statements at a time. And doing that, now I have 1 2 3 4 5 6. So if you say that let's print the welcome to Java statement 6 times, you will just repeat this one statement which is there on line number 4, that is printing welcome to Java 6 times. All right, okay, so I got this thing printed out 6 times. Well, fine, very simple, right? But this is not programming. Alright, so what I'm doing right now is considered really bad, and it is called hard coding. It's one example of doing hard coding which you should never ever do. Alright, why? Because we're not smart. If somebody is saying like that this welcome to Java should be printed 6 times, then what I'm doing, I'm just copying that statement on 6 lines and getting that to work. That's okay, that's fine, but I will not consider that as a very good programming. Because what we'll think about a case where somebody can say that let's print welcome to Java 100 times. So what will you do? Will you type these things 100 times? Well, you may, but that is not programming, right? That's not fun. That's not what we have to learn, right? So the message that you should be getting right here from this discussion is that when we have to do the same thing, what is the same thing here? Printing the statement which is welcome to Java a number of times, right? This number of times can change. Right now I have it as 6. It could be 100. It could be even 1,000. Now we don't want to do it the way a layman will do by typing it those many times, like printing it over 100 lines. I have done it for 6 lines, continuing to do that for 100 lines. That's not smart, right? So what we will do now, we will learn about looping. We'll learn about the iterative structure, which will help us to write the same program in a more systematic way. So what I will do, just to give you some idea about it, well, I will explain that in detail. Let's do it in a smart way. Let me declare n is equal to 6. So I want to print it 6 times. So what we can do, we can use a loop. We will learn about that. While loop, we have a couple of other loops like do while and for loop. but let me just use it. Okay, I'll tell you like uh, how to write that, so don't worry about that for the time being. What I'm doing here is I'm just making use of that without explaining to you how will that work. Okay, I plus plus. I'm going to explain everything to you, but right now I'm just showing you that if you could somehow make use of these loops, then this task becomes so easier, right? And that's fun. Now, right, see 1 2 3 4 5 6. So just start typing hello, welcome to Java once, and putting that in a loop. So while is a loop structure which we will learn today. Now, how did it help? How did it make my life simpler? Well, I just wrote that once, and I made this loop to iterate over n number of times, which is 6 here. I can change that. I can make that to 10, and the same code will run and it will print welcome to Java 10 times. Okay, right here 1 2 3 4 5 6 7 8 9 10. This is very simple. The example that I've taken is very simple, but I believe this is good enough to give you some idea about the beauty of iteration, the beauty of a loop. And this is not hard coding. Okay, previously it was a hard coding when I was typing welcome to Java, or where I was writing this system.out.println statement 10 times, 6 times, 20 times, right? It depends on how many lines I need to print that. Okay, so this is the problem that we have in our motivation as well. So back to my lecture slides. Now suppose you need to print a string welcome to Java, which depends on the user input, which is capital N. Okay, so let me use pen. Okay, alright, so it depends on the user input N. If N is equal to 20, you should print it 20 times. So here you see, you know, on the basis of N, you will have those many system.out.println statements. Now, if you make use of loop the way I did, and initially we will learn about while loop, then see the life is so simple and so beautiful. Okay, yeah, you start with a counter variable. I'll tell you what is the purpose of a count in a typical loop, but for the time being what we are doing, we are initializing count to 0, and then before we get into the loop we will check the condition. We'll check whether count is less than n or not. Only when count is less than n we will go inside inside this while loop. We will run that system.out.println to print welcome to Java, and since you have printed that once, so you need to record that. And how do we record? We record this information about how many times we have run the loop in this count variable. Alright, and this count will only equal n when you have printed the statement that many times. Alright, so that's how while loop works. Don't worry, I am going to discuss while loop in detail in the next few slides. But the purpose of this slide was to motivate you towards a learning loop. Okay, and it will happen in your exam, it will happen in your homework, so please keep your eye open, right? Look for the case where you can use loop. Alright, so wherever possible please use loop. Don't do something like this. Okay, this thing if you're doing, I will consider that as hard coding and you will be penalized for that. So wherever possible please make use of loop. Alright, so well, as I said that this loop belongs to the iteration, so we will try to understand like what is iteration and when should we use it. So iteration means that whenever you have to repeat some statements, right? So when you are repeating some sets of statements, then that means you are doing an iteration. Alright, so let's look at some example. Suppose you're writing a program in which there are these, in the line number 1, say you have instruction 1. In the line number 2 you have instruction, in line number 1 you have instruction A. In line number 2 you have instruction B. In line number 3 you have instruction C, and after that there is some condition, and after checking the condition, if the condition is true, you are coming back to instruction A, instruction B, instruction C, back again instruction A, B and C, back again instruction A, B and C. So you are forming a loop here. Alright, so whenever you form a loop, and in that loop you are running the same set of statement multiple times, then that will constitute an iteration. Okay, that will form an iterative construct. Alright, so here in this iteration that we have, there are only three statements, or you may call them instructions: instruction A, instruction B, instruction C. And after doing instruction C, you check some condition. If the loop condition is true, you will go back to the first statement that we had in the loop. Alright, so this is more general, and in this discussion we are communicating this thing to you, that this is what we'll call iteration, and what can we have in a typical iteration. Okay, so what will happen here, if we open this loop, then it will result in the execution of ABC followed by ABC followed by ABC, so on and so forth, and we will continue to do it as long as the condition for the loop is true. Okay, so there's one more thing which you should keep in mind. We iterate, or the iteration is based on, iteration is conditioned. Alright, we will only run this iteration or the loop as long as the condition for looping is true. Alright, good, let's move on. Okay, so why use iteration? Well, it will make our code very efficient, more readable, I will say. Let me add one more term, readable. Okay, you can read the code, it will be very simple, it will be beautiful, it will be more compact. So it will make our code more practical, efficient and readable. And it is more flexible, you can change it whenever you want to. If you remember, I had just one, I had int n is equal to 6 when I wanted to print welcome to Java 6 times. Then I changed n to 10, and after that I was able to print the same message 10 times. Okay, so it is more flexible if you use loop. Now let's look at an interesting concept, or the mathematical formulation, which is called factorial. Right, so first I'll explain to you what is factorial, and then we will try to look into the program, like how should we write a program to compute the factorial. Alright, so what I should be doing here, let me first explain to you what is factorial, because I noticed that some students, they did not have any idea about factorial in the past semesters when I taught this course. So what is a factorial? Okay, so it's a mathematical concept. When you are given some integer like n, alright, so if n is given to me, I will call n factorial. So this is the symbol for factorial in mathematics, and this n factorial is equal to n multiplied by n minus 1 multiplied by n minus 2. You go on multiplying it till you reach 1. Okay, so let's take some example. 5 factorial. What is 5 factorial? So if you put this 5 factorial thing in this formula, then you'll figure out that 5 factorial should be equal to 5 multiplied by 5 minus 1, which is 4, multiplied by 3, multiplied by 2, multiplied by 1, and you stop at 1. So if I say how much is this value, then it should be 6, this is 5, 4, 20, this much, and then this is 6, 120. Please double check, I believe it is 120. Let me know if it is wrong. Similarly, you can do 6 factorial also, which is 6 into 5 into 4 into multiplied by 3 multiplied by 2 multiplied by 1, which should be 720. I know that 5 factorial is equal to 120, right, from the above computations. So 6 factorial should be 6 times 120, which is 720. Alright, so now when you know what is factorial, then let's see how can we write a program for that. Alright, so n is something which we will get from the user. The user will say that, okay, compute 3 factorial. If n is equal to 3, then well, yeah, I'm using small n for n, that is the same thing. When the user is saying n is equal to 3, you need to compute 3 factorial. If the user is saying n is equal to 5, then you should compute 5 factorial. Alright, so let's have a look at it, right? We will first try to write a program that will not involve any loop at all. Alright, so we will make an attempt to write a program which will compute n factorial without using any loop structure or any loop construct. And then after that we will look at a loop and we'll see that how much loop has improved our programming. Okay, so fine, let's have a look at this approach where we are not using any loop at all. So what do we do in the first statement? Here we are asking the user to input some values. So you're prompting the user by with the help of the system.out print statement, asking the user to input n, which should be an integer. Then you get that value in n using a readInt method of keyboard. What is keyboard? Keyboard should be your scanner object. Okay, so we have done that a lot. You know how to use a scanner class, how to use the scanner class to create a scanner object. And once you create that scanner object, then you can use that scanner object to invoke readInt method. And we need readInt because factorial is something that is computed on integer values, positive integers. Okay, fine. So how do we compute that? Well, we are saying that, let's compute that factorial and keep that factorial in a variable which we are calling as factorial. Okay, so excuse me. So here factorial is being initialized to 1. Why? Because if you want, you can get some idea from here. So what you should be doing if you have to compute a factorial, so from programming a point of view, what you can do, you can store initialize factorial as 1. Alright, integer factorial is equal to 1, and then what you will do, if the user is giving you some value, if n is equal to 2, then what do you do? Then in this case you will say factorial is equal to factorial, which is 1, multiplied by 1, well anyway it is 1 multiplied by 2. Alright, so this factorial thing we can use in order to compute the factorial for n. So the same thing we are doing here. So how do we solve this? Well, let's take the case where n is equal to 0 or n is equal to 1. Alright, so well, in the factorial definition which I have here, we have a 0 factorial as 1, right, and 1 factorial is also 1. Alright, so this definition you can take from mathematics, which we have right here. 0 factorial is 1, 1 factorial is also 1. So you can use that concept and you can return factorial as 1 when the n which is input the user is providing is either 1 or 0. In both the cases, in the case where n is equal to 0 or 1, factorial will be 1. Okay. Alright, if the input that user is providing is not 1 but in place that is 2, then what do we do? If n is not 1 and not 0 but n is 2, then what do? Then factorial is equal to 2 multiplied by 1. Fair enough, right? That's how we define factorial 2. Alright, if n is 3 is not 1, 0 or 2, then you are taking care of that in the third else if statement. Okay, and here you compute factorial as 3 multiplied by 2 multiplied by 1. Good, there's nothing wrong with it, right? And in case n happens to be 4, well, do 4 into 3 multiplied by 2 multiplied by 1. Alright, as if n is equal to 5, similarly you can compute factorial 5 as 5 into 4 into 3 multiplied by 2 multiplied by 1. This is making some sense, but you should wonder, like, where are we going, right? If I say that compute the factorial of 10, right? If you have to compute 10 factorial, think about it. How many times you write else if, else if, else if? Alright, so, well, you can write this program to compute factorial as long as n is 5 or 6. Beyond that, it doesn't look like a flexible programming. It looks like a really bad programming. Alright, so the message with this slide is that you can think of writing the factorial program without using iteration, but that program would be horrible. Alright, the way you're looking at if, else if, else if, else if, else if, it will be very, very lengthy, right? And it will break, right? If you have some patience, then you can probably write some 100 lines of code taking care of n is equal to 100. But after that, what will you do? N could be 1000, n could be even more, right? So this style of programming would also be called as hard coding. This is also hard coding. Why is this hard coding? Because your program is not general enough. Your program is just based on some values of n. So till now you can only return factorial up to n is equal to 5, right? So this is not flexible enough. This is hard coded. It will work for only certain cases. It will not work for all the cases. Why? Well, because we did not use a powerful construct. We did not use iteration. Alright, and if you use iteration, you can write this program really, really well, which will be very flexible and which will be able to compute the factorial for large number of for a larger value of n, and you won't have to write if else statements like this. Okay, so what should I do here? Alright, well, I'll have to use eraser here, so give me some time, please. I'll use eraser so that I can write a program using iteration for factorial. And this is a very common program which I will encourage all of you to write yourself, and make sure that you are able to write this program correctly. I don't mind how many attempts you take in writing that, but eventually I want you to be able to write this program. Don't hesitate in asking for help, but this is a very fundamental but very important program that you need to write. Alright, so how will you compute this factorial? So what I can do is, once I'm done with this explanation, I will write a demo for you. Or maybe we can do that after covering while loop properly. So what should I do here? Let me initialize factorial is equal to 1. Okay, now alright, I should have an if statement. If n is greater than 1. Alright, if n is equal to 1 or less than 1, which is 0, then fine, factorial is 1 anyway. If n is greater than 1, then I need to go in this if body and I need to compute the factorial. Now how should I do that? I will use the while loop, which I will explain, don't worry about that. So int I equals 0. Alright, I is is a variable which I'll use to figure out like how many iterations I have done. So what do we do here? We will say while, sorry about this thing, you should write here while I is less than n. What do we do here? Factorial is equal to factorial into n minus I. Alright, and you should do I plus plus. Okay, so this way you will be able to compute the factorial for any value of n. So let me show you that this is correct by running it for n is equal to 5. So when n is equal to 5, what will happen? Your I will be 0, factorial you initialize to be 1, okay, and n is greater than 1, right? So what you should do, I is being 0 here, you check is I less than n, that is correct, I has been 0 and 0 is less than 5. So what do you do here? You will say factorial is equal to 1 multiplied by n minus 0, which is 5. Okay, and next time what you're doing I plus plus, so I is equal to 1. In the next iteration, I is equal to 1, and you go back to the while statement. I will explain to you how while works, okay, just for the reason that I've written this program, so I feel I should give you some idea, and then anyway we will discuss while, and I'll be back and I'll explain this again. Okay, so when you made I plus plus, then being a loop, it will come back. That's how while loop works. Now I is equal to 1, but n is equal to 5. 1 is less than 5, so the condition is true. You will go again here. And here, now factorial is equal to factorial, which is 5. It was already 5. 5 is to be multiplied by 5 minus 1, which is 4. Alright, then you will increment I plus plus, I will become 2. When I is equal to 2, 2 is also less than 5, you come back here and you will set factorial is equal to factorial into whatever this was multiplied by 3. Okay, and then you will do multiplied by 2, and after that what will happen? Then you will have multiplied by 1, and finally when I will be equal to I will be 0, 2, then 3, then 4, and when I is equal to 5, then 5 is not less than n, and you come out of the while loop. Alright, so using this while loop, you will be able to compute factorial, which will be equal to 5 into 4 into 3 into 2. Alright, which is in fact the 5 factorial. Alright, so this is how we can write factorial programs so efficiently. Alright, okay, so one such version is right here, which I believe is very compact. Alright, so this is very compact and you may have some difficulty understanding it, but what I have written right here is the same as what you have in my next slide. Okay, so what we are doing here, you are getting the input in n from the user, factorial is being initialized to 1, you have this variable I which will keep track of how many times have you run that iteration. Okay, so now as long as I is less than or equal to n means the number for which you are computing the factorial, we can take that as 5, the way we took in the previous slide. So while, which means as long as your condition is true, as long as the condition is that I is less than or equal to n, we will keep updating factorial. How? Factorial star is equal to I plus plus. So this is little tricky, so let me break it down for you. It is equivalent to factorial is equal to factorial multiplied by I and then I plus plus. I plus plus means you're changing I to, you're incrementing I. So when I was after this thing, what will happen? A factorial will be multiplied by I, which is 1 here, and then I changes to 2, I plus plus. That means I will be changed. I will be incremented by 1. So I becomes 2, you come again, you check the condition. If 2 is less than or equal to n, then you'll go inside the while loop, or otherwise you'll come out of the while loop. Okay, so you might find this little strange because without even explaining to you how while works, I'm showing the use of while. Okay, so well, I think you'll have to wait a little longer, maybe for a few more slides. But don't worry, I will explain to you how while works. And then I'll come back to these slides. Alright, so here we are looking at the different iterative statements or constructs which are available to us in Java. So Java provides us three such statements, three iterative statements. A while loop, which I've been using till now, a do while loop, which is slightly different from a while loop, and then a for loop. I think I have already given you a flavor of for loop when we were doing string, and hopefully you are using for loop already, because if you've done homework 1, you have used for loop. But don't worry, we will discuss for loop in more detail than what we have done till now. So all these three loops that we have, they are similar to they have a lot of similarity, and in most of the cases you can use one in place of the other. Like while loop and for loop are very similar. It is sometimes it's personal choice, like which loop to use, a while loop or a for loop. So for factorial example that we have done, it can be written using a while or a for loop. Both the loops are good for this case. Okay, but we will also have a look at like do while loop, which is slightly different. Okay, so that we'll discuss, like how is do while loop different from while loop and also for loop. And I'll give you some hint, like despite the fact that while loop and for loop are similar, you can solve one problem, you can write a program using a while loop or a for loop, but there are certain cases where while loop work better than the for loop, and for some cases it is when I'm saying works better, it means that it is more convenient to use while loop in place of for loop. In certain cases, for loop is more convenient to use in place of the while loop. Okay, so that's what we say, that it's a matter of individual preference or convenience in most of the cases, like which loop you want to use. Okay, so now let's look at the while loop. Like how does a while loop work? So this is the general structure of a while loop, and right here we have the flowchart. So when you write a while loop, then with the while loop in the parenthesis you have a condition. Alright, so this is Boolean. It will result in either true or false. Okay, so this has to be a Boolean expression. So while loop is written with while, and then in the parenthesis you will have a Boolean expression which will return in true or false, and this is called the loop continuation condition. If this condition is true, then only you will run the body. Otherwise, you have to come out of the loop. Okay, so let's look at this flow chart. So what is this flow chart saying? Flow chart says that you come here, right, and you check the condition here. Condition is loop continuation condition. If the condition is true, then only you should be running the loop body. If the condition is false, no point. You should not run the while loop at all. Okay, good. So if you got this, simple flow chart, then let's try to understand that with an example. Now, we have a variable, count variable, which has been set to 0. Now, here is this Boolean expression that I was telling you. This is Boolean expression. Count is 0. You will check whether 0 is less than 100 or not. It can result in either true or false. So, when you just enter this, say this was line number 1, line number 2. So when you're coming to line number 2 for the first time, then your count is 0. So when the count is 0, then 0 is less than 100. So here we have true. It is true. So for the first time, the condition is true, which will take you inside the while loop. And inside the while loop, you are printing this statement, which is welcome to Java. And after doing that, you are incrementing count. So count was 0, you made it 1 now. Now you should wonder, like, why are we incrementing the count? Well, we are incrementing the count because we are using this variable count to remember how many times we have run this while loop. Alright, so count is a very important variable here, which is keeping track of the number of times we are running this while loop. So before entering the while loop, count was 0 because you did not run that even once. When you came inside, count was 0, the condition was true, you printed one statement which was welcome to Java, and after doing that you said, you know what, I was able to enter the while loop once, so let me take note of that. And how do you take note of that? You take note of that by incrementing count to 1 because you have run the while loop once. Well, fine. After that, what will happen? It will take you back to while. Alright, so this is a loop. It will take you back. Once you're done with the body of the while loop, it will take you back to the condition. Alright, look at this here. This is loop. What you do, if the condition was true, you go inside, you run the statement of the while loop, and after running that, you don't come out. You need to go back and check the condition again. If the condition is true, you will continue to loop for one more time, right? You will continue to loop as long as the loop continuation condition is true. Alright, so fine. With count is equal to 1, we'll go back, we'll check the condition. Is 1 less than 100? Yeah, you're right, it is less than 100. So you will run that again. So after printing welcome to Java second time, your count will be 2. Okay, because you printed it 2 times. 2 is less than 100? Yes. So you'll continue to run this as long as your count is less than 100. So you will print that 100 times, right? After doing that 100 times, your count will be 100, right? Count will be 100 when you print it 100 times. Then with count is equal to 100, when you go back in the loop and check the condition that 100 is less than 100, then here the result would be false. 100 is not less than 100. 100 is in fact equal to 100. So count will be equal to 100. It will not be less than 100. So this condition will be false and you will come out of the loop. Okay. So the same thing which I explained to you is written here in the form of the flowchart. So initially what you did, your count was 0. Well, in the condition, the Boolean expression you are checking, you are asking this question. Is count less than 100? Well, if that is true, then what are you doing? You are printing welcome to Java, and at the same time you are incrementing count. You are making count plus plus. Alright, because if you don't increment count, then you will lose track of how many times you have run the while loop. Okay, and if you don't increment or decrement count, if you don't update the counter variable, okay, so let me tell you about this thing. This count variable that you have, which you can have count or I or j, whatever you call it, but it is being used to control the execution of the while loop, is called the loop counter variable. Okay, or loop control variable, loop counter variable, whatever you call it. But the purpose of this variable is to control how many times your loop will run. Okay, so this is very important. In your while loop, you have to update this count loop control variable whenever you run the loop. Otherwise you'll get stuck in something called as infinite loop. Okay, I'll explain to you what an infinite loop is later. Alright, so let's trace this program. Okay, so fortunately I have this animation which should help you. So initialize the count. Count is 0 here. You check the condition. This program is written for only 2 iterations, so it's simple to follow. You check the condition. Is count less than 2? Yes, the result is true because count is 0 here. You print welcome to Java. Then you increment the count. So when you do count plus plus, that means count is equal to count plus 1. Okay, so now the count is 1. You see that right here. Now the count is 1 because you do count plus plus, and count plus plus is same as count is equal to count plus 1. Okay, good. Alright, so now count is 1. So it's a while loop. After the end of the, after executing the whole body, you need to go back to the condition checking. Back to the while. Now, count is 1. Is 1 less than 2? Yes, that is correct. 1 is less than 2. That means go again, right? You deserve to go inside the while one more time because the condition is true. 1 is less than 2. Well, you print this statement welcome to Java second time, and then you increment count. When you increment count, now the count is 2. Well, you have to go back to while. You check this condition. Is 2 less than 2? Because count has the value 2 now. Is 2 less than 2? Unfortunately not. Count is equal to 2. Okay, so it will take you out of the while loop. Okay, good. Alright, so before I do while loop, I will write this. Okay, why to write? Let me take you back to the slide where I had written this program. Okay, so now we understand how while loop works. Okay, so we know that while loop works with a variable called counter. So loop control variable right here is my I. I is the, okay, sorry about that. I need to go back to pen. I should use pen here. Good. So for this factorial program, this I is my loop control variable. It will control, look at this one, right? How many times I'm running the while loop depends on the value of I. As long as I is less than n, I will compute the factorial. That means I will execute the while loop. And when I is equal to n, I will come out of it. Alright, so what do we do? I is equal to 0 and factorial is equal to 1. I have done that, and I am checking the condition. If n is greater than 1, then only I need to do all this hard work. Otherwise, I know that for I is equal to 0 and also for I is equal to 1, factorial is 1. If n is greater than 1, then I should run this while loop where my condition is that I should be less than n. As long as I is less than 1, I will loop. And what is it that I am doing in the while loop? I am computing factorial is equal to factorial multiplied by n minus I. Okay, so initially I was 0 when I was 0, so factorial is equal to factorial multiplied by, if n is 5, then it will be factorial multiplied by 5, which is 1 multiplied by 5. You have to increment I plus I, right? Because why do you increment I? Because you you have already been in the while loop once, so you should make that 1, right? So I should be changed, it should be incremented to 1 because you did the multiplication into factorial by one term, which is 5, which is n. Later on, when I is equal to 1, you check this condition, is 1 less than n 5? Answer is correct. So later on, what you do, you multiply, you update the factorial by multiplying it with the second term, which is n minus 1, that is 4. Later on, when you do it uh, the third time, it will be multiplied by 3. Fourth time, multiplied by 2. And fifth time, it will be multiplied by 1. Okay? So what I should do, let me write a program for you. I will discard. Okay. So here, let's make it very, very general. So for that, I should use a scanner class. stdin is equal to new scanner system dot in. All right, and here I should say enter a positive integer. Okay, so let me int n is equal to stdin dot next int. Okay, I should be capital. Okay, good, it fixed that, right? Now let me close this thing, stdin dot close. All right, so here I will follow, I'll try to write the program in the similar way as I have written in the lecture slide. If and okay, sorry about that, I should have factorial is equal to 1. If n is greater than 1, then we need to do all this hard work. Otherwise, factorial is 1 anyway. So how do we do that? We need another variable, right? The counter variable. So in place of using I will call that count. Count is equal to 0. Now how do we check, what do we need to do here? While count is less than n. What should we do? Factorial is equal to factorial multiplied by n minus count. All right. Well, you might be wondering, like, in place of n minus count, if I do factorial multiplied by count, that is correct too, but then you'll have to do count plus 1. All right. And the most important thing is we need to increment count. All right. And then here we should print that integer input and factorial is equal to factorial. Okay, so fine, let's run this program. I will input some values. Let me give you 3. So factorial of 3 is 6. 3 into 2 into 1. 3 multiplied by 2 multiplied by 1, which is 6. Let's try that for 5. 5 is 120, right? We did that. of 720. So you can, try those things, and I believe this is correct. It should be. Now there's another thing. As I said, the students, they might be wondering, like, if in place of multiplying that by n minus count, why not multiply that by count, right? That is also possible. So the point is right here. Okay, so you might say that, why is this guy doing this way? What I am doing factorial is equal to factorial multiplied by n minus count. That is what I am doing. Alright, and then I am doing count plus plus. That's one way. Alright, so this way if you do, then 5 factorial would be computed as 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, right? Some of you might be wondering, like, why now? See, how about this? Should I, if I do it this way, like 5 factorial is equal to 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5, can I do it this way? Answer is yes, you can do that. So let me give you a message right here. It's possible to write, it is possible to write more than one program to solve a problem. Most often you will be able to solve a problem in more than one way. Okay, then we think about it, like which is the efficient and which one is not. But for this case, both are equally efficient. So what you can do is factorial is equal to, you can do that. So you will do count into factorial and then count plus plus. You can do that, right? So both are same, but here for this case your count should be initialized to 1. You should say int count is equal to 1, and then you should work on this. In this case, your int count should be initialized to 0. Alright, I hope these things are making sense to you. Let me go back and try the same thing on the program that I have written. I will discard it again. So here I need to change the count to 1 because I want to do it the other way. And here count has to be less than or equal to n. Count. Okay. So let's run that, and for 4. Alright, so 4 into 3, which is 12, into 2, 24, right? This is correct. If I try that with 5, 120, okay, with 6, 720, alright, and let's do this boundary case where I'll say 0 is 1, okay, good. So please try these problems, okay, this will give you a good confidence booster. Now it is important to understand at least one loop. So while loop is decent enough. So from while loop you can learn that. Now do while is a very interesting loop and is my favorite loop in my exams. I love to ask question on do while loop. Okay, so how does a do while loop work? So do while loop is slightly different from while loop. Let's look at the structure. So here, alright, wait a second, I need my pen. Okay, so look at this structure, right? We have a do, and then there is the body of the loop, which is in between the opening and closing curly braces. So whatever you want to have in your the loop body, you can keep that in this block. After that, then you have a while loop, not while loop, then you have while. Do, and then in the opening and closing braces, you will have the body of the loop, which will have some set of statements, and after that you have this condition. Alright, so what does it mean? Since we have changed this thing slightly, it is not same as the while loop, it is a do while loop. So how does it work? Let's look at the control structure or the flow chart. So here what will happen is that first we will run the body of the loop. So first we run the body of the loop, and after running the body of the loop or executing the body of the loop once, then we check the condition. Okay, in case of while loop it was different. Let me take you back to while loop. In the while loop you first check the condition and then you execute the body. First condition, then you execute the body, you come back, you check the condition, execute the body, check the condition. So the difference between a while loop and do while loop is that, look at the while loop. Before you enter the loop body, you have to check the condition. Only when the condition is true, you get to execute the body of the loop. Whereas in the case of the do while loop, you don't check the condition first time. You get first free ride into the body of the loop, and after the first free ride in the body of the loop, you need to satisfy the condition to enter the body second time. First time is free. Alright, first time you can enter the do while loop, whereas for the second time if you want to re-enter the loop, you need to satisfy this condition. Alright, and this condition is same as the one you had in the while loop. Okay, so while loop is at the bottom, right? And in the do while loop you have do, then in the opening and closing curly braces you will have the whole body, and after the body you will have a while. Alright, while with a similar kind of condition. And the most important thing is a semicolon. In the while loop we did not have a semicolon, but in do while we do have a semicolon. Right, this is where the student miss the point in most of the time. This is where the students they miss it out. Alright, if you don't have a semicolon, you will get a compiler error. Alright, so keep that in mind. So one more time, let me write a while loop for you. In the while loop that we have written till now, this is how we write the while loop. Here you will have the body of the loop, which will have some statements, and here you have loop condition. No semicolon, right? No semicolon here, no semicolon here. While followed by the condition, which will determine whether you can enter the body or not. So if the condition is false in the very first attempt, you will not get the chance to enter the body. Whereas in the do while loop, the condition is towards the end of the loop body, right here. The condition is not here. Condition, if I say this is 1, this is 2, then the condition is at position 2. In the first position we don't check anything, you are allowed to enter the loop body once, and after that you come to while and you check the condition. If the condition is true, then you go back. If the condition is true, you go back and run the body. You come again. If the condition is true, go again. If the condition is false, just exit. And the most important thing, you need a semicolon in the do while loop. Alright, so I hope you will be able to follow this flow chart, where you come here, you run the body once, you check the loop condition, the condition is false, come out of it, and if the loop condition is true, go back and run the loop body one more time. Now you might be wondering, like, we are giving a free ride in the body of the loop. Why is it useful at all? So the answer to that is yes, it is useful. In a lot of cases, you may want the body of the loop to run at least once. Okay, so there are some programs called as menu driven program. So in menu driven program, a do while is very useful. So let me explain to you what a menu driven program is by giving you an example. So here we have written a menu driven program. I will encourage you to type this out and see how does it work. So let me explain to you what this program is doing, and then I'll tell you like why is it menu driven and all. So here you in is a scanner object. For that you're using scanner class. Scanner in is equal to new scanner system dot in. I hope you should know that. Then I have a variable called selection. Its type is string. Then you have a variable called counter, and this counter variable we will use to control okay, so we are not using it to control that, fine, but we will keep an we will use it to find out like how many times we are running the loop. Okay, fine, so it's an integer variable which is being initialized to 0. Good. So let's see like how should we write do. Pay attention to the text that I have in red. So do you start the parent you start the curly brace, and then you end the curly brace, and here you have a while statement. What is there in the while, we'll come to that later, but yes, the most important thing is that we have a semicolon here. So this condition we will understand later. Let's leave that for the timing. Do and while, right, and then a semicolon there. We will look at this condition later. Let's leave that for the timing. Now what is a menu? Let's try to understand that. So the first statement says that system.out.println choose a menu option. Okay, so what are the options available? Second statement is saying that you will have p to print the counter. Counter means this thing. And system.out.println q to quit the program. Alright, and then you have system.out.print enter. Enter means it will prompt the user to enter a value. And then selection is a string variable, and in the selection you're asking the user to put some input. Alright, so what are the possible inputs? P or a Q. Alright, so what are you saying? You are saying, choose a menu option. Options are P or Q. If you say P, then it will print the counter, whatever value the counter has. And if you say Q, then it will take you out of the loop. Q means quit. You don't want to run this loop anymore. So these are two options. P, that means it will print the counter. That will give you the idea like how many times you have been inside the loop. And if you say Q, then it will take you out. Okay, so fine. What are we doing right here? We are capturing the P or Q, whatever the user inputs in the variable selection, and the type of selection is a string. Now if the selection dot to upper dot equals P, right, so these things we have learned in the previous class, right, on its string. So what we are doing, we will see the user can enter P or can enter capital P. Alright, for printing the user can say small p or capital P. We need to treat these two as same. So what we are doing, we are changing that. If it was lowercase p, we want to change that to uppercase. And if it was uppercase, well, uppercase to uppercase would be the same thing. So because of this statement which says selection to uppercase, it will change whatever p, whatever it was, small p or capital P, to uppercase, and we'll check whether it is equal to p or not. We are checking what the user wants. User wants to print the counter or wants to do something else. So if the user has input small p or capital P, then this condition would be true. And what do? You print the counter value. Alright, fine. And after doing that, it could be true or it could be false. If it is false, don't worry, you are coming right here. If it is true, even then you are coming right here. After running all these statements, you come right here in the while. Right, now we need to see what is happening in the while statement. Now what you are doing here, similar to the way you have done selection to uppercase, you do selection dot to uppercase to change whatever selection you had made to the uppercase. and then you check whether your selection was Q, right? And your selection would be Q only when you input either small q or the capital Q. Now if your selection was Q, then what do? We don't want to run that again. Alright, so if your selection was Q, right, so this will return in true. If you selected for Q, then a small q or capital Q, then using a selection dot to uppercase, it will be capital Q. And if that is equal to Q, that means you wanted to quit, you said a Q, then this whole will return in true, this part only, true. And after true, when you put a not, this is the not operator, okay, so this not operator will make it false, so the result of this will be false. And if it is false, then you don't want to go again, right? You don't want to re-enter the do while loop. Alright, otherwise, if it was false, right, if your input was not Q or Q, any other input, then this whole will return in false, and the not of false, which will which will change the true to false, false to true, it will result in a true. If that is true, then it will take you back to the while loop. Alright, so the message is that using this do while loop, you are able to enter this loop at least once. Alright, and once you are inside the loop, now it is up to you. What do you want? If you want P, good, it will print the counter. Alright, and if it is anything else, then it won't print, but it will opt you to come again. But if your input is Q, then it will take you out of the loop altogether. Alright, if it is P, it will print the counter. If it is Q, it will take you out of the loop. If it's anything other than P and Q, then it will take you back to the loop, the way it will do for P also. Now here, while you are printing the counter, you should keep in mind that we are printing the counter and we are incrementing as well. Right, so here we are incrementing as well. How? Okay, so we are incrementing because we are doing what? We are doing counter plus plus. Alright, you are incrementing counter also. So excuse me, I don't know how well I did, but I still have a feeling that you might have some difficulty in this part. Alright, so please pay attention to this slide, and if you have questions, please reach out to us, to me or to my TAs. Okay, so please look at it with focus. You need a lot of focus to understand this slide, but it's not too complicated, right? Okay, good. And run this thing, type it out on your IDE and see for yourself how is it working out. Alright, so now we have the same program, right? So if you run that, then this is the menu. This whole is your menu. It's called menu driven program because this is your menu which you want to be shown at least once. Alright, you want it to be shown at least once, right? So whenever you have a menu driven program, you should use a do while loop because we want to run that at least once. Alright, so this whole thing that you have is making your menu right here. Alright, choose a menu option, P for print counter, Q for quit. So when you say P, the counter is 0 because it was 0, and after that it will change. Right, look at this thing, it's counter plus plus. If it was plus plus counter, then you'll see 1. Right, you see 0 because it is post increment. First the value of the counter, which was 0 here, would be printed, and then the value of counter would be incremented. Okay, good. Now you got another option. Your input P, it was not a Q, so it will take you back to the loop. So you got the same menu printed second time. This is the menu, okay? And here it is saying P for print counter, Q for quit, and you said A. Alright, so A is none of these options, neither P nor Q. So it will not print the counter and it will not quit. Right, it will take you back to the same menu. Now if you say P, then the counter has been changed to 1. Okay, so the counter is equal to 1 is printed out and you get the what? The menu again. Alright, and then when you say Q, then it will say goodbye. Alright, where do we have goodbye? We have goodbye right here towards the end of your program. It's a very interesting program actually, so please try that and try to understand what we are doing. Now to our favorite loop, which is for loop. And this is something that I kind of gave you some idea about when I posted some information on string along with the for loops. So in most of the and I'll say a lot of problems dealing with the string, you can use for loops. And let's see, like, how do we write a for loop? So this for loop, if you look at, it has 3 parts in it. This is part 1, which is loop initial action. This is initial action, and these 3 parts of the for loop, or 3 parts you can say, yeah, are separated by a semicolon. So initial action separated by a semicolon, followed by a loop continuation condition, just like the condition which you had in the while and do while loop. And then you have the third part, which is the action after each iteration. Alright, and then you have the body of the for loop. So let's try to look at the way all these 3 statements here in the for and the body, in what order these things are executed in a typical for loop. So this initial action that you have is taken first. Alright, and then after the initial action has been taken, after this one has been done, then you check the condition. Right, you check whether you are allowed to enter the loop or not. Okay, so if this condition is false, then you should immediately come out of the for loop. After initial action, you check the condition. If the condition was false, you cannot enter the for loop even once. Right, so it's very similar to while loop in its execution. It's not like do while loop, which lets you enter the loop at least once. Okay, the condition must be true. If the condition is false, you cannot run the body. Alright, so after taking the initial action, you check this condition. So usually whenever you see a diamond, then diamond means that you are deciding, you have to make a decision on the basis of some condition or Boolean expression. If the condition is true, then you run the body, and the body will have sequence of statements. You run the statement body, and after running the statement body, then you do the action after each iteration. Alright, so 1 and 2 is done in this sequence, 1 followed by 2. 1 is initial action followed by condition checking, and after condition checking you run the body, and only after running the body you come to the action after each iteration. Alright, and then after doing this thing, after doing the action after each iteration, you check the condition one more time. Alright, so from this you come back to loop continuation condition. You run the loop, then you come back to the action after each iteration, then you check the loop condition. In this order it will go on. Okay, so the same thing you should see here in the flowchart also. Initial action followed by the loop continuation. If the loop continuation condition results in false, you come out of the loop. If that condition is true, then you need to run the whole body of the for loop. After you are done with the body of the loop, then you need to do action after each iteration, which is the third part of your for loop. Okay, and then you check the condition again. So let's take an example, and I believe this example will make it a lot simple to understand. We have a variable I. Alright, so which is outside the for loop, and here there are these three parts of the for loop. This is part 1. I'm putting that 1 because this is the thing that will do the first part, always the first, right? Initial action before even taking the decision, I is equal to 0. Then the second part, the second thing that we do in sequence is checking the condition, is I less than 100. So I is 0, right? I was declared here before the for statement, but in the first part of the for statement we initialized I to 0. So since the I has been initialized to 0, so we can do this comparison. We can check whether I is less than 100 or not. So condition is true, right? 0 is less than 100. So we don't do this part, okay? The next thing that we do is we take an action on the basis of the condition. If the condition is true, we will go inside. Alright, so we will run this statement, which will be our third statement. 1, 2 and third statement. Condition is true, I will go inside the body. I will say, so welcome to Java. And after doing that, right, after doing this thing, what I do, I will do action after each iteration. And what is the action? Action is right here. I should come back to this third part. I should come to the third part of the for loop after running the body. Okay, if the condition was false, I will never, if my very first condition of the for loop was false, I will never reach the third part of my for statement. Okay, I will come to the third part of the for statement only after running the body at least once. Okay, good. So 1, 2, 3, 1 initialization, which is the initial action. Second, the condition checking. Condition was true here, so we go on and run the body, which is third part. And the fourth part, we will do action after each iteration. And then my fifth part is condition checking. I will never go back to the first thing, right? Initial action is only once. We don't do initial action multiple times in for loop. If the condition was true, you will go back and you'll run that again only when the condition is true. If the condition is false here, you will come out. Assuming condition was true, as is the case, like I will be 1 here. Okay, it was 0, but when you do the action after each iteration, it will be incremented I plus plus. So it was 0, it will become 1. So 1 is less than 100. You go here, 6. That is the 6th step. After that, you come here, the 7th step, in which I will be 2, and then 8, then 9, and then 10, then 11, alright, and then 12. You go on as long as the condition is true. So these numbers that I have here is showing the sequence in which your program will run in this particular situation. The same thing you will find in the for loop also. I was 0. You check, is I less than 100? Well, yes, that is the case. It is true. So you will print welcome to Java first, and then you do I plus plus, which is the action after each iteration. Go back and check the condition. Is 1 less than 100? True. Do it one more time, right? So you will continue to do it 100 times. Alright, and after that, when I is 100, then your condition would be false and you'll be out of the for loop. Alright, so now we need to decide, okay, like which loop is better. So for loop are popular for counting loops. So counting loops, right? This is a new term that has come. So we need to understand what is counting loops. So counting loop would be a situation where you know how many times you have to run the loop, right? Like this example here. You know that you have to print welcome to Java 100 times, right? So it is so simple. You can write all all the important things that you need for a loop, like initialization, condition checking, and incrementation, everything at one place. Okay, whereas in while loop you will have something like this. If I have to write a while loop corresponding to this case, what I will do, int I equals 0. That's my initialization part. Then I'll have a condition. The condition would be while I is less than 100. Alright, and then this system dot out, I'm not writing that complete statement. You can figure out it's the same thing. And then I will do I plus plus. Alright, so this first statement, which is initialization, the second statement, which is condition checking, and this statement, which is incrementation. In while loop, it happens at different places. This line here, then this line here, and this line here. So because of the fact that in while loop we have these three important loop controlling statements at three different places, so this results in bugs a lot of times. So while loop is more prone to bugs compared to for loop. Why? Because in for loop you write all these three things at one place. Okay, so for loop has these three important things at one place, like initialization, condition checking, and the incrementation, which makes for loop more compact, easy to use, and less prone to bugs. Alright, so wherever you have such a simple case of looping, where you know how many times you have to loop, and you know that in every iteration you are incrementing it by fixed number, like you're incrementing by 1 or incrementing by 2 or similar constant value, it's very simple to use that with a for loop. Okay, so what could be the cases? Well, if you are dealing with strings, right, if you have to print every character of the string, or if you have to check whether the string has a numeric character or non-numeric character, whether the string has uppercase, lowercase, vowels, all these things, right, where you are required to visit each character of the string, right, and which is very systematic. You have to traverse the string by visiting one index at a time, or maybe accessing every character, one character at a time, using the indices, right? So for most of the cases involving strings, it's better to use for loop. All right. Okay, but again, it's personal choice, so I don't want to spend too much time on it. When you program, you will get to know which loop to use. So let's trace a for loop to understand this thing. We have an I, declared right here. Then in the for loop, the very first thing that we are doing is initializing it, because in the previous statement we just declared it. It had no value assigned to it. In the first statement of the for, we initialized it to 0. And then the second section of the for loop, which is important, that should come after first segment, is the condition checking. You check whether I is less than 2 or not. So 0 is less than 2. The result is a true, which means we have the permission to go into the for loop. You go inside and you print the very first time, welcome to Java. After that, you come back to the execution of the increment statement, which is the statement after each iteration. So here we are incrementing I, we are making it plus plus I, which means I plus plus, which means let's update the value of I, or increment the value of I by 1. So after that, you check the condition again. Condition is true, 1 is less than 2. Okay, so we run this one more time. We will print welcome to Java twice, the second time. Okay, back again, you increment I, now I is 2. 2 is no more less than 2. So this condition is false. It will take you out of the for loop. Alright, and we are done with the for loop. Now, the initial action for the for loop, here we can look at, this is an interesting example, I will leave that as an exercise for you, because if I explain everything to you, probably you will miss out some important thing. Let me put some stars here, meaning that it is important. See what is happening and try to reason. I'll be very happy to answer any question if you have on this. Okay. Well, let's look at this one. This is, difficult, right? This is difficult. That's the reason I'm leaving it on you, so that you could think over it. Please think over it. Okay. All right. So what do we have here? So you can have more than one initialization. In this case, which is simpler here, look at it. We have just one initialization, just one condition checking, and only one incrementation. You are allowed in this first part, you can initialize two variables, I is equal to 0, j is equal to 0, and the condition involves I and j both. Okay, so this is slightly slightly complex compared to the previous cases, where in the initialization we had just one variable, in the condition checking we had just one variable, in incrementation also we had one variable. In this slightly interesting case, we have two variables I and j initialized to 0, and they are declared as integer 2. Integer I is equal to 0, j is equal to 0 means we are declaring two variables I and j of type integer, initializing them to 0, and then our condition is based on the fact that the sum of I plus j should be less than 10. And the third part, we are incrementing I as well as j. Alright, so these things are allowed. So exercise again. This exercise is to write some statement here. How about this? Print I plus j. Just print I plus j and see what's the output. Alright, good. Now what are infinite loops, right? This is very important thing. So this is initialization, right? You should have initialized something. This condition you should have checked condition, and then you should have the incrementation. Now if you write a for loop in this way, then it will result in an infinite loop. Infinite loop means it will continue to run forever and ever. So this is something we would like to avoid. So how do we avoid? We should have some condition checking here. Alright, if you don't have a condition checking, then probably it will run forever and ever. Alright, and you should somehow make sure that this condition should be false. It should result in some false condition, otherwise you will be running forever and ever. Okay, so infinite loop is bad news, and when you do loops, then very often we get into the infinite loops. We get trapped in the infinite loop. Okay, and there will be certain cases when you are doing programming, you will encounter cases where we do not properly handle the loop control variable. So if you do not properly handle loop control variable, then you will get into the infinite loop. So let me do this thing as a demo. I can take you back to the program which I had written, and I can show you some infinite loops. So here, this count is my loop control variable. So the condition is that if my count is less than or equal to n, then only I should be running my while loop. And the way I have set up count is that after running every while loop, I am incrementing count. So from count as 1 to n, it will increment, right? So there will be a point when count and n will converge. That means they'll have the same value. So the way I have written the program, it is guaranteed to converge, and when it converges, then that means that count will have the same value as n, in which case our while loop condition will be false. And when the condition is false, then you will come out of the while loop. Let me do this here, count minus minus. So let's try to understand what will happen. If in place of incrementing count, if I decrement the count every time, then you can very easily see that my count is decreasing in every while statement, right? So when my count is decreasing and n is remaining constant, this condition that count is less than or equal to n will be true always. Alright, so when this is true always, I will have an infinite loop. Let me run that. Okay, let me say 5. So you know what? This is the infinite loop. Wait a second. How about this? This should be an infinite loop too. Alright, so this is an infinite loop. This is running and running forever, right? This is running forever. Look at this red thing. I will have to force it. It's not terminated yet. I will have to force it. I will have to terminate. Okay, so these are infinite loops which we need to avoid. And infinite loop means that you are never out of that loop. You are stuck there. You see, this is being done all I don't see a red here. Alright, so infinite loop is a situation where your condition for entering the loop is always true. So when your condition is true, when the condition is true and you're entering the loop over and over and over again, then you will be never able to come out of the loop, right? Which is a bad news. We want the loop to terminate. If the loop is not terminating, then that's a bug. Alright, so when your while is true, you will be running it forever. That's called infinite loop. There are some interesting cases, like if you put a semicolon here, right? We don't want a semicolon here. We should not have any semicolon after for loop, right? So look at all these cases when the for loop was given, right? When introduced, we did not say that you should put a semicolon here. Only in the case of do while loops you should put a semicolon after the while thing. In for loop we don't put a semicolon here. So now let's see like what will happen if by accident you put a semicolon here, right? So well, the answer to that is it's not a compiler error, it's a logical error, right? So what will happen if you add a semicolon at the end of the for clause, then what will happen, this will terminate right here. Okay, this will terminate right here, and this for loop will have no impact on the statement that is coming afterwards, right? So let's try that. Let me give you a demo on this. So what are we doing? Let's write a simple program, a very simple program in fact, using for loop. For int I equals 0, I is less than 5, I plus plus. Alright, and what do we have here? Welcome to Java. Alright, so it should print this thing 5 times. Why? Well, you are starting with I is equal to 0, you check condition, is I less than 5, it is true, you print it out first time, and then after that you come here, now I will be 1, is 1 less than 5, yes, you print it twice, you go on doing it and you will print it 5 times, right? So I got this thing, 1, 2, 3, 4, 5. Now let me put a semicolon here. Is it a compiler error? No, not at all. Do you see any red here? No. Now let's see what will happen if you do it. I think you'll get only one welcome to Java statement. Alright, yeah, you got just one welcome to Java statement. Why? Because this for loop that you had written, you killed it right here. It is ineffective. right? It is ineffective, it is doing nothing. Now if I try doing something here, okay, wait a second, right? uh, this is what you had there. Now what will happen, right? This is the statement that I have left for you as an exercise, right? Let's see. You got 0, 1, 2, 3, 4. Why? You need to think about why did you get it, right? So you remember I have some stars in my lecture slides. You have something like this here, right? So why are you getting something here? Why are you getting 0, 1, 2, 3, 4? You need to reason about it, okay? And don't be surprised if I ask you the same question in exam. Another motivation for you to work on that. Good. Back to my lecture slides. So putting a semicolon here is a logical error. I might need a pen, so let me go to pen right here. Okay, let's move on. So same thing you can do for while loop also, right? You will kill the while loop right here. While I is less than 10. So what will happen? Here it should be an infinite loop. So another exercise for you. Infinite loop. Please confirm. Is that an infinite loop? If yes, why? Okay, check. But the point is, it is a logical error. It's not a compiler error. Okay, so that's a mistake. We often make these mistakes. So we should be careful about it. Now, which loop to use, right? So, well, these are, I mean, as I said, it is your personal choice which one you use. We can replace one loop for the other. Like if you have a while loop written in this way, then you can write a corresponding for loop as well. But that for loop would be very interesting for loop, because you have nothing in the initialization. This is blank, and you have nothing in the third segment of the for loop, right? So you can write a while loop with a for loop also, exactly the same way you can write, where you should not have any initialization part, but you do need to have the condition part. This is must, okay? You cannot leave this part. Alright, and the last part also you can skip. So similarly, when you have for loop, then you can write a corresponding while loop by taking this initial action out of the while loop, right, just before the while loop. Then the loop condition you can have in the loop condition part, and this action after each iteration will happen as the last statement, right? So very straightforward, very straightforward. And the message right here is that it is possible to directly translate a while loop to a corresponding for loop, and similarly, given a for loop, you can straight away translate that for loop to the while loop. Alright, so let's look at it, right? What will happen here? This is an interesting example. You have a variable, you call that as sum, and your j is initialized to 1. J has to be less than or equal to 4, and you're doing j++. So this is perfect, right? I don't see any error in this, I mean any logical error in this program. You initialize j to 0, j has to be less than or equal to 4, j++. And what you're doing here, you're saying sum is equal to sum plus j. So after looking at these 1, 2 and 3 statements, you should get some idea that what you want to do is, in sum you want to add all these things. What? 0 plus 1 plus 2 plus 3 plus 4. That is your intention, right? That's what you want to do, right? From 1, 2, 3. That's the that's what I understood. But we have a problem somewhere. The problem is right here. What's the problem? Well, when you started with this is not happening actually. You wanted to sum in this way, but this is not happening. Why? Look at it. Your sum is 0. Alright, so you started with j is equal to 1, j should be less than equal to 4, 1 is less than 4, you go inside, you say sum is equal to sum plus j. So sum is equal to 0 plus 1. Okay, then you do j plus plus, that means j is 2 now. Alright, it was 1, you made it 2. And then you're back again here, and what are you doing? You're doing j plus plus again. So that makes it 3. Right? So now j is 3. Is 3 less than 4? Yes, it is. So you will add 3. You missed 2. Right? Why did you miss 2? You missed 2 because, after making, here it was 2, but you incremented here again. That's how the for loop works. This statement that you have has to work. It will be effective when you come out of, when you finish the body. After finishing the body, you need to execute this last part. Okay, so what happened? Because of these two, you're incrementing j twice. Okay, so j was 1, then j became 3. Is 3 less than 4? Yes, it is. So you go back again, you added 3, and right here it will become 4, and then it will become 5. Now is 5 less than or equal to 4? No, you come out. Right, so your sum would be 4 when the sum should be 4 plus 3, 7, 8, 9 and 10. Alright, so this is not what you needed to do. So be careful about it. Sometimes you might commit these mistakes. If you love using while loop and you're using for loop for the first time, then you might commit this mistake. How to fix it? Well, take this off or take this one off, right? Yeah, anything will work. You can remove this guy right here, or you can remove this guy right here. But don't remove both. If you remove both, then you are in an infinite loop. Just one. Alright, so sometimes, it all depends on how you are writing your loop. Sometimes people prefer using a flag. So what we are doing, we are writing the same program, which is factorial program, but here we are using a flag. So what's the purpose of a flag? So flag is a boolean thing. So you declare more work flag as boolean and you mark that as true. So how do we make use of it? We are writing a program for factorial. You say int factorial is equal to 1, just the way we had done, and then you have written a while loop, and this while loop is conditioned on your flag, more work flag. So while loop is saying that as long as it says that you have to do more work, I'll keep on looping. Alright, so while more work flag, I will loop. And what are we doing in this loop? We are computing factorial as factorial. This is equivalent to factorial equals factorial star n. Alright, so we will multiply by n and you are incrementing, you are decrementing n. Now if n is equal to 1, then we'll say okay, we are done. Alright, n is equal to 1 means that we have multiplied all the terms that we had to for computing factorial. Alright, so if you had to compute factorial 5, then it means for the factorial thing that you have, which is equal to 1, you need to multiply that by 5, then by 4, then by 3, and all these values you are keeping in n by decrementing n. Then you multiply it by 2, and when your n is 1, then that means we are done. We don't want to continue looping around. So how do we reflect that in this particular implementation? Whenever you have n is equal to 1, we will set this more work flag as false. So this being false will anyway take you out of the while loop. Alright, so if you get it this time, great. If you don't get it, don't worry too much. You will anyway understand that if you somehow understand the remaining 40 slides in this lecture. Alright, so how does it work? We have this explanation right here. I wish to stop this video lecture right here, otherwise it will become too lengthy. The next part of the video lecture I will post very soon. Thank you so much. Please do those exercises that I left for you. This is a very important concept of looping, so please pay attention on this. Thank you so much. See you later.